Hey guys, Caden here from Kesselcraft Studios, and in today's episode, we're not actually talking anything about Deadwood Drive. I will mention though, if you're looking for Deadwood Drive content, it is coming very soon. I have a video update for you guys, as well as a big update for the game itself coming very soon, so stay tuned for that. But what is today's video about? Today's a challenge I wanted to do that I've seen across YouTube and the internet. You may have seen it as well. Is like a 48-hour challenge or like a weekend challenge, whatever you want to call it, to make a game in just a couple days. So on top of making a game in a couple days, I wanted to use the first part of this video to kind of show how I set up Deadwood Drive and how I'm going to set up all my games going forward, because it's set up in a way that, and to me, is organized, and it helps me work with Unity in a very efficient way, if you will. So all of that to say, we're going to do a 48-hour challenge. I'm going to post this video and content to itch.io on Monday. It is Saturday right now. And we're going to go over the basics at the beginning. So there we go. Now, what kind of game am I going to make in 2 days, you might ask? Well, I have a game idea called Snake Chase. So like I said, the first section and what we're doing right now is going to be the setup, how to make a Unity project from scratch, how to organize it and get it going. The second section, which I'll probably do tomorrow on Sunday, is going to be actually adding in all of the Snake Chase content. So Snake Chase, you know the game Snake. You're playing as a 2D snake, you have to eat things, and you get bigger and bigger, and you can't eat yourself, and you can't run into walls and stuff. You probably know the game. What I want to do is make a 3D version of that, and you're the snake, you're slithering around in 3D, you have to eat mice, and it'll first off just be one level, of course, but the mouse will be moving around, and you have a set amount of time to eat this mouse, and if you do it, you win. If you don't, you have to reset and do it until you get it. Now that is the Snake Chase game idea, and if people seem to like it, I will make it a further, more levels, an actual full-fledged game. But today, I just essentially want to make one level, make a start menu, and that's pretty much it. So I think I blabbered for a good couple minutes straight. Let's jump into the code. Okay guys, so before we actually dive into Unity or any of the code or game development stuff, I just wanted to put this on the screen so you guys know the main differences of the pipelines and which pipeline I'm choosing in Unity. If you're familiar with Unity, you know there are three pipelines, or three major pipelines: the built-in, the URP, and the HDRP. I'm not going to go over these verbally. They're on the screen here. Just read them if you'd like. Pause, take a moment. Just know that I'm going to be using the Universal Render Pipeline, also known as the Lightweight Render Pipeline. That's just what I wanted to use today. So there you go. Okay, so if you create a new Universal Render Pipeline project in Unity, this is what you're going to get when you open it. I am on Windows, so there might be minor differences on those operating system software based things. But just know that this is basically what a blank Unity project looks like. So just real quickly, I'm going to go over the main tabs that we'll be using today. And when I say tab, I mean this. Here is a tab: Hierarchy, Scene, Game, Animation. Here's another section: Inspector, Lighting, Occlusion. Down here we have Project Console. So these are what I mean by tabs. Now let me highlight the main ones we're going to be using today, and the main ones you're probably going to be using in your Unity development. That will be the Hierarchy tab, the Project tab, the Scene and Game tab, and that Inspector tab. Now, the Project tab holds all the assets and all the content of the game, essentially. So in here, you're going to have, your models, your materials, your terrains, your textures. Pretty much everything you're going to be using is in here. The Hierarchy is how those things are connected together. They're linked parent-child relationship. You can drag and drop things to connect them together, house them together, organize them in a folder structure you'd like. Over here is our Scene tab. It goes along with the Game tab. Now the difference here is the Scene is what it looks like when you're editing the world, and the Game is what it looks like when you're playing it. And of course we have our play and pause buttons up here. We'll get to that in a moment. Over here on our right we have the Inspector tab. So anytime that you click anything in your Hierarchy, you can edit its settings, edit its properties over there in that Inspector tab. Now we're not going to touch lighting, occlusion, console, animation. We're not going to touch any of that stuff. That's more advanced topics. We're just going to touch the very basics today. Okay, so the first thing that we want to do is go over here to our Scenes tab. We want to we'll delete this example scene in a moment, but we're going to right click, go to Create. We're going to go to Scene. We're going to rename this to Level 1 or whatever you want, but I'm going to call it Level 1. We're going to open up Level 1, We're going to delete that example scene, and here we are. Now a new scene that we created will only have a main camera and a directional light, which for right now we're going to delete both of those, so our hierarchy is actually empty. Okay, so we're in the level 1 scene. There's nothing in our hierarchy. Okay, so the first thing that we're going to do is we're going to add some structure to our hierarchy before we even add any of the world objects or the player objects or the camera or anything like that. That way we have a defined structure for our project from the start. So over here in the hierarchy, I'm going to right click. I'm going to click create empty. Now what this is going to do, it's going to create an empty game object. It's going to be called game object. Now before I go any further, I am going to touch base on game object in Unity. Game object is a generic term for a folder or a container for everything else in Unity. For example, your player model is going to be a game object that might have a 3D model mesh with some scripts and some physics on it and some lights. Your world will be a game object that might be terrain. It might be a cube or a sphere. A game object, everything in Unity is a game object. It just essentially means a container for things. Now we will use game objects as folders in the hierarchy, and you will see in just a moment how I'm going to do that. I'm going to name these a specific way and then tell you in just a moment why I'm naming them that way. Okay, so now I've got two empty game objects in my hierarchy. I'm going to give that a quick save. One called world and one called player. You might notice I've got these formatted a little bit weird, and there's actually a reason to that. Now nothing else outside of the main folders of the hierarchy will be labeled with these equal signs like this in the all caps. Everything nested below our world and player will be, you know, Pascal case or proper case as it's called. The reason I do it like this is that way I know what my main folders are of the project, and I can quickly go to the world, quickly go to the player. Sometimes you might have a UI layer or a save layer, whatever it may be. If you name your main layers this way, you'll see as we progress through this basic project even how helpful that can be in terms of locating things. So first things first, I want to create something for our world. We got to have a place to play on, right? So in our world folder, we're going to right click, we're going to go to 3D object, we're going to go to cube. Now what I'm doing here is making our level 1 basic project here just a flat piece of ground. Now what you can do is add a terrain or add whatever you want to be your level, but for here it's just going to be a cube. So I'm actually going to rename this cube by pressing F2. I'm going to rename it to ground. Okay, now you'll notice over here that when I left click ground, the inspector tab, you'll see all the options for this. Now I actually don't care about any of this. The only thing I care about right in this moment is this scale property on the transform section in the inspector tab. So once again, we're on the ground object, then we look in the inspector tab on the transform section on the scale property. We're going to put, let's say 100 on the X, 100 on the Z, and we can zoom out by scrolling here. Now we've got a nice big flat piece of ground to play on. That's all we really need for our world for this first level. So we're going to give that a quick save. We can close up that hierarchy. So now we need a player, right? So in our player object, we're going to right click. We're going to go down. We're going to go to create empty. Now what I want to do here, instead of just adding that ground object and just labeling it itself just like that, I've created an empty game object that I'm going to rename player model. And in the player model, I'm going to add a 3D object that will be a sphere. You can move it around if you go to the move tool and the transform tools there. Just make sure that you move that, and you can zoom in and out. Make sure you can see it properly. Make sure that that sphere is above your ground, of course. You don't want it to be below. There we go. We move it a little bit more up. All right, so we got a sphere above some ground. So now we have a player sphere model, and we have the ground. We don't have a camera or anything to view the world with, so if we were to click play, I don't think anything would even happen because we don't have a camera. Yeah, black screen, exactly. So what we need to do now is add a camera. Over here in the hierarchy, I'm going to right click the player folder. I'm going to go to camera, and there we go. Now, this camera, when you spawn it by default, just as I did, it tells you if you zoom out, you can see where it's looking, right? That view box is where that camera is looking, and it may not necessarily and probably isn't going to be focused on where you need it to. And just to simplify this view, I'm going to close that inspector section. Okay, so if we go to the view we were on, looking at the world like this, get your situation however you'd like. Okay, just like that. Now, instead of trying to fidget with the camera and these arrows and moving it left and right and up and down and spinning it with the rotation, it's just a pain to do it like that. The easiest thing you can do is get your view. Let's say I want the camera to be looking at the world like this, let's say. We're going to right click on the camera in the hierarchy. We're going to go to Align with View. We're going to click Save. And now when we click Play, we'll be able to see the ball as we see it now. See, that's what the world looks like when we're in the game and in the scene. If we switch between those sections, just like that. So as you can see, I mean, nothing's going on. Like, you can't, nothing's hooked up. There's no code that tells it to move. There's no controllers that tell it to move or anything like that. So that's what we got to do next. Okay, so before we do that, I want to grab that player model, grab the sphere, and you'll see when you click the sphere in the hierarchy, you'll see that you got the sphere mesh, the renderer, and the collider. The collider is what tells Unity, hey, if there's physics involved and this hits another collider, two colliders hit, that's a collision. There's supposed to be a physical reaction, like a bounce or a crash or, you know, some sort of reaction. That's what colliders do. But without a rigid body, or that's what Unity calls its physics system, is adding a rigid body to an object would be adding physics to that object. And you could edit the physics of Unity, but by default, they're all to Earth standards. To add the physics to the ball, because like I said, when you click it, nothing happens. It's floating there. It's not like falling because there's no weight to it. Very simply, select the sphere in the hierarchy tab, click Add Component in the Inspector tab. I've already got it here typed out, rigid body. We're going to click rigid body. We're going to close up that sphere collider section, and we have the rigid body section right here. We see the mass of 1. I'm going to change that to 10. Now by default, this is in kilograms. You can edit this to be whatever you'd like, but by default, it's in kilograms, and the units are in meters in Unity. Okay, so now when we click play, it's got some physics on there, right? So the ball should fall, and it does. Sweet. But now we have no way to control it still. We need to control the ball, so when we click play and it falls to the ground and we click our keyboard keys here, our directional keys, we want that to move, right? So we need that to be hooked up with a script. So to hook up a script, before we add anything to the hierarchy, what I actually want to do is over here in our assets folder in the project tab, we're going to create a folder called scripts. Because the way scripts work in Unity is you actually have to create them in your projects folder and then add them to that hierarchy object. So in our new scripts folder, we're going to right click, click create, C# script. We're going to call this player movement. It's going to check that script is valid, make sure there's no errors, and of course it's a brand new default script, so it's good to go, and we are back in action. Okay guys, before we dive into the code here, I actually have to talk about how you even work with code in Unity and on a computer in general, and that's with an editor. I'm not going to dive into this topic because you can spend a lot of time on it. I'm just going to say I use VS Code by Microsoft. It's a free code editor for working with projects and code alike. I very much recommend it. It's free. Please get your own, whatever you prefer. It doesn't really matter as long as you have some sort of editor. Okay, so now that we have an editor, we can start working with this code. So if we double click our script right here, it should open it with our default editor. Like I said, mine's VS Code, so it should open that right up, and you'll see this. This is the default script that Unity provides you when you create one inside of it. It has start and update, and as the comments say, this is run the first frame. This is run on every frame update. Very useful. We will actually be using these. I'm going to just remove the comments for now. And this is actually all we need. We just need these default functions. We're not going to add anything else to get this ball rolling, so to speak. So it's once again going to check that our script is valid. It's going to be, because all I did was remove some comments, and it even shows you a preview right there. I've pasted in the code that we need so I don't have to spend time typing it out, and we can just cover it quickly. So in our player movement script, we have 2 variables and 2 functions. Those same 2 functions we started off with, of course, start and update, and then our 2 variables. So we have a private variable, meaning it cannot be accessed outside of the script, not even in the editor of Unity. It is a type of rigid body, meaning it's a physics body. We are calling it RB for short. We have a second variable, it's public, meaning other scripts can access this, as well as the editor in Unity can change its value without having to go into the editor like we are here. It's a type of float, which means it's a number. We're calling that speed and setting it to 5. At the start of the script, meaning at the first frame, we are grabbing the rigid body off the component in the sphere. We know that this script is on the sphere, and on that same sphere is that rigid body. That's what this is doing. You would get an error if that was not the case. Let's say you had, we're not doing it here, but let's say you had a script in a different spot where there was not a rigid body, but you wanted that script to control that rigid body. You would change this private to public, and then you would edit it in the editor over here in Unity. But for now, we're just going to leave it as private because we know our sphere has that physics on it directly. So that's our start script. In our update script, or every frame, we're creating 2 numbers, 2 floats, one called move vertical, one called move horizontal. Those are input values from our keyboard, which are input, these are grabbing inputs set up from Unity's input manager. By default, these should be active for you and for me. Vertical for up and down, and horizontal for left and right. Those return numbers between 1 and 0. Now we're taking move vertical and move horizontal and applying it to our rigid body through the add force function. Now we're taking the movement, which is pretty much a combination of the horizontal and the vertical, times our speed that we set up here. So long story short, we're grabbing up and down, we're grabbing left and right, we're applying it at the speed that we set in the editor to our rigid body. So now if we come over to Unity, we go to our player model, we go to our sphere, we close the rigid body so we can see this easier. We drag and drop our script. We make sure our speed is set to 5. And now when we click play, our ball should move. There you go, guys. Okay, guys, so now that we know that our game works, one thing you may be complaining about or may be noticing, and I certainly do, I just haven't said anything, of course, is that, hey, this looks pretty bland. These are the same color. Can't we get some color in here? Can't we get something, a little bit different than just gray? And the answer is yes. So as a piece of bonus content, we will real quickly add a material to our sphere, our player model, so we can more easily see it against that gray ground. So in our assets folder of the project tab, we're going to right click, we're going to create a new folder and call it materials. Now all the materials for your game should live in your materials folder, of course. So in the materials folder, we're going to right click and click create and go down to material. Now we're going to call this player material. Alrighty, now that we have a player material created down here in the project tab, we can click it to see it in the inspector tab over here, and on the surface input section we have the base map property, which we can click this color box and now we can select its color. So I'm not going to get too far into the color and the opacity and the way that textures and materials work in Unity, but just know that this is a very simple way to change the color, and I'm going to do that. I'm going to make it a teal color, and now all I got to do to make that sphere a teal color is I can drag and drop it in the hierarchy. And just know you can always drag and drop it into your scene as well. I just have more, accurate, more efficient responses and clicks when I drag and drop it in the hierarchy instead. So now that is teal, and now when we start the game, we should easily be able to see our ball. All right. That's it, guys. Section 1 complete. Okay, guys, so on to section 2 of the video, which is the actual 48-hour challenge portion. Like I said at the beginning, that first portion is just to kind of show you guys my thought process on setting up a brand new project in Unity and kind of going through those basic steps with you, kind of like a guidance tutorial, if you will, just because I like doing that sort of thing, and I know people out there like seeing that as well. So hope you enjoyed that. If you're skipping to this point, no worries. We're on to the actual Snake game. If it's already complete, it's already posted on itch.io as of last night. That link for the game on itch.io is in the description below. if you want to go play the game, which I encourage you to please go do and check it out there. Now, before we actually get into the code or what the game development in Unity actually looks like, I did just want to go ahead and show you guys what the end result of the game is. So, real quick, I am going to open up the game and we will play it. Alrighty guys, that's pretty much it for the demo for the first level of Snake Chase that I made over the weekend. There's nice little music going, there's a start menu, there is a countdown timer when you're playing, control with the directional keys, there's a win screen and a fail screen if you happen to not make it. Either way, you restart at the beginning of the game when you reach the end. So very basic, but it does simulate that snake movement, does simulate a very basic mouse movement, mouse evasion pathway. Now it's time to jump into the Unity project. I actually don't want to give away all the good stuff, all the secret sauce to that snake movement, because I did spend a little bit of time trying to make that work, and there was some examples I found online, but they didn't actually work exactly as I needed them to. I had to make some customizations for this game, which I will improve upon in the future. So in that regard, I'm going to keep some of my secret sauce secret, but I do want to dive into the structure of the game in the Unity project for sure. So let's jump over there now. Okay guys, here we are in the Unity project. I'm going to leave the view as is, and I'm just going to talk about kind of how it's structured based upon the previous section of this video, starting with the hierarchy. So over here in the hierarchy, I do have those levels for UI, game, player, and world in the special format to keep them structured. And you can see how useful this is when you have multiple things in here and you need to sort through very quickly. So real quick, in the UI, like I said, we have the fail, the winner, the player UI, which is the countdown, the start menu, and the event system that controls it all. Then in the game layer, we have our song, and we have the time manager that controls the pausing and the song playing and pausing as well. In the player layer, that's funny. In the player layer, we just have the player model, which is pretty much how the snake works is, we zoom in here, it's just a sphere that uses a special script to generate other spheres and move like a snake. And attached to that sphere is a camera. The camera is literally just attached to the model, so it moves with the model. There's no script controlling that camera. In the world, we have the mouse, which is consisting of a square and a set of waypoints. And I didn't know this until this project, but Unity's Universal Render Pipeline, the URP, which is what we're in this project, actually highlights the waypoints as a path when you label them correctly, which I did not know that. In the HDRP project I have for Deadwood Drive, I have a bunch of waypoints over there, and they don't actually show up like this on the screen, so this is super handy. But like I was saying, that mouse model is just a square and some waypoints for its path. We got the walls, the boxes, the ground, the big ground outside of that ground, and then the sun up there. That's pretty much it over there in the hierarchy. Now I do want to touch base on just one more thing here in Unity project. We'll close up this stuff to make it a little more easy to look at. In the player movement script, we are able to set the speed, the steer speed, or how fast you're able to turn, how fast the body moves behind you when you move, the gap between all the parts, the prefab to generate the rest of the snake with, and the game time manager for pausing and starting the game when you collide with the mouse. Like I said, I had to do something a little bit special over there in the script, so I am using a rigid body on the snake and the mouse, but the snake's rigid body is kinematic. And I'm having to do something special and handle those collisions very explicitly in a way you might not normally do in Unity with like your collision handler or your trigger handler. I have to handle that manually because of the way the snake works and the way it has to work with the environment. So that's pretty much it. Alright, thank you guys for tuning in. I hope you enjoyed. I hope you liked what you saw. I hope you are inspired to go make your own 48-hour game challenge or just make something in general. I love game development. I'm going to keep doing it, and I hope you guys enjoy watching it because you got more coming. And speaking of which, very, very soon, as mentioned previously in the video, and I'll probably mention it a million more times this year, Deadwood Drive is coming very soon. We're going to have a demo launch very, 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 very soon. I'm going to have a video coming for that as well, so stay tuned for those updates. And I think that about covers it for this video, guys. So until next time, peace.